Today we are going to work on categorizing all those formulas we've learned how to balance. And this is called types of chemical reactions. And for this level of chemistry, we are going to categorize it into 1, 2, 3, 4, 5 different types of chemical reactions. We have combustion, we have synthesis, and when we synthesize things, that means coming together. So we have two people coming together in a marriage. That's an analogy for synthesis. And decomposition is when things break apart. So these guys were married for a long time. It didn't work out, and they broke apart into two different species. We have single replacement, and I like to think of this like a dance. We have a single and a couple. They come to the dance together, but this guy's lonely and he wants to steal this guy's date, so they switch partners. That's a single and a couple, so that's a single replacement. And we have a double replacement where we have two couples coming to the dance and they don't really like each other, so they swap dates. And that's an analogy for a double replacement. Right now, I either handed you this paper or you have it at the end of your packet, and what we're going to do is we are going to fold it like a hot dog. Okay, so take your thing, fold it in half, and we have this lovely foldable. This is not something that you can use as a reference sheet on a test. You have to memorize these 5 chemical equations. Now, combustion. This is our first formula I'm going to talk about. And when we go through and categorize, I want you to pull out your combustion reactions first. If you don't do that, I have students get messed up and think it's a decomposition or a single replacement or something like this. While it is true that some combustion reactions can also be a synthesis, we're going to pull out our combustion first so we don't make any mistakes. Okay, so the first thing to know is we have oxygen as a reactant, and that is really how we're going to identify our combustion reactions at this level of chemistry. So what do we look for? We look for oxygen gas as a reactant, okay? And I might have 2 products. I might only have 1, but this is what we're looking for. And oxygen gas is a diatomic element. It's O2. I could have 2 of these. I could have 8 of those. But if I have O2 alone, that's oxygen gas. Let's look over here. This right here is not oxygen gas. This is carbon dioxide. Make sure you're looking for oxygen gas. Here we do have oxygen, but this compound is a water. Again, oxygen gas, and it is on the reactant side. Okay, so O2 is a reactant, which makes it on the left side of the equation. Okay, now a lot of times we are burning carbon and hydrogens. That's called a hydrocarbon combustion. If we burn carbons and hydrogens, and there may be other things with this carbon and hydrogen in this compound, we will always make carbon dioxide and water. So these are our products. Carbon dioxide and water will always be our products. Okay, here we're burning magnesium. It's not a hydrocarbon combustion, so these are the products that we're going to make. But it is a combustion because oxygen is our reactant. I've now highlighted these 2 reactions together, and I like to call these sister reactions. And RXN is our shortcut for writing reaction, and that's because these 2 are very similar. In synthesis, we have 2 things that come together and form one compound, and this is like our marriage. So Again, two things come together and they form one product. So what are we looking for? We're looking for only one product. That's going to be our key, okay? Now, why do I think they're similar? Well, this is completely the opposite. Here I start with one reactant and then they break apart. Things decompose if you bury them in the earth and they break apart into pieces. This is a decomposition where we're breaking apart into pieces. Okay, so for this guy, we are looking for one reactant. And this will give you a clue if it's synthesis or decomposition. Here we can see I have two reactants and they form one product. They came together, they got married, and that is a synthesis. Here I have one reactant and it breaks apart. This is hydrogen peroxide. It breaks apart into water and oxygen. I started with one reactant, it broke apart into pieces, and that's how we figure out our decomposition. Our next two reactants I also call sister reactions. And these reactions are similar to me because I think about them as a dance. Single replacement and double replacement can sometimes also be called single displacement or double displacement. And what I think about is we have A, and A's alone. It's a single element. I could have 5 of them, but I only have one capital letter there. And it goes to the dance with this couple or compound, which is B and C. Now, A is very lonely, and so it is going to try to cut in and steal B's date, and they will swap places if A is strong enough. And now A will be dancing with C, and B will be left alone. Here we have zinc with the couple that's hydrogen and chlorine. Zinc's all alone. It's going to try and steal hydrogen's date, and it's strong enough to do it. So now zinc can move over here and dance with chlorine, and hydrogen will be left alone. So what are we looking for here? We're looking for a single element plus a compound on both sides. So we have a single plus a compound on this side as well. Okay, now a single element doesn't mean that there's only one of them. For instance, O2 is a diatomic element. I could have 5 of those. That's still considered a single element there because there's only one capital letter. I'm going to erase this, but I did want you to understand that when we're looking for this, it's not about the big numbers in front. It's about the letters. If I just have one capital letter, I've got a single element. 2 capital letters, I've got a compound. Okay? We will do another lesson that shows you how to decide if A is strong enough to kick out B, and we'll be using an activity chart with this. Okay, so if I want to look at single replacements for this class, we are going to consult our activity chart. Our last reaction is a double replacement reaction, and again, I think about this as a dance. I have two couples. Why? I have 2 capital letters, so I have 2 compounds, okay? And the thing about A and B is they don't really like each other, and C thinks D smells, so they're going to switch partners. They're going to switch dates. So now A is no longer dancing with B. A moved over here, and A is dancing with D. C moved over here, and C is dancing with B. So we are just swapping partners at a dance. And here's your example. We have sodium and chlorine, okay? And we have silver and fluorine. And again, they don't like their dates for whatever reason. We don't know. They don't like their dates. So these 2 guys right here are going to switch spots. Sodium was dancing with chlorine, but now it's over here, so sodium is now going to be dancing with fluorine. Here it is. Silver goes over here, and silver is dancing with chlorine. So that's our dance. And what are we looking for so we know it is a double replacement reaction? Well, we have two couples there. Where here we have a single and a couple, but I like to say we have two compounds on that side, and we have two compounds as our products. So two compounds is a reactant, two compounds is a product. Versus here we have a single element in a compound as a reactant and a single element as a compound as a product. We will go on to practice these types in the next lesson.